Python works. How Python works with multithreading. What is the problem with the GIL I told? How we are contributing. So GIL is an issue, but it doesn't mean that it will not allow us to do the concurrent tasks. But still we can do the concurrent tasks. At the same time, you should be aware of few other things. The basic definitions of all the things and how it works. Now, if you see any task, tasks are of two types. Means anything related to the IO operations, like reading a file, reading from a network, reading from a database, or writing to a database, or writing to a file. All these things are IO bound tasks. Any tasks are of two types, either IO bound tasks or like CPU bound tasks. So IO bound tasks means like they have some kind of time waiting, right? You ask something from the database, you need to wait for database to reply. Similarly, CPU bound task means what? Everything is up to you. Let's say you want to calculate, say, a Fibonacci numbers or like some prime numbers. You need not wait for others, right? So what is the performance depends on, the entirely depends upon your CPU itself. So those kind of things are CPU bound activities, and these are called as IO bound activities. So Python in this, as multi-threading has this kind of problem where we have a GIL issue. Sometimes it will make the thing sequential, right? So that's why they say, like, for IO bound task, it's better to go with multi-threading. For CPU bound task, it's better to go with multiprocessing. That is a conclusion. So, and what is a thread? Any process which is running. So, process and thread are like the most commonly interchangeable things, we say. So threads means like any process which is running, which will be working with some kind of resources, and these resources can be shared. Whereas process means if it has everything on its own. Whenever you're creating one process, we give like a separate resources, like separate some amount of memory, some amount of processing power, like that, everything we give independently. Whereas for threads, it's not the case. You just create it, everything will share the resources. So that's the beauty of threads actually. And in threads, there is one type of thread is called as daemon threads, which I showed yesterday. If some threads are executing in the backend, irrespective of what you do or not, so they will execute in the background job, like a background jobs. Those are called as daemon threads. And the next is about the thread synchronization. So thread synchronization, why we need the thread synchronization? I told you yesterday, the same thing I'm repeating again. If you have like multiple threads which are running, and if you want to communicate with them, or if they want to share something, there should be some kind of synchronization. If everything is executing in its own way of time, so we don't know like how to communicate, right? There should be a proper way of doing this. That's where synchronization comes. And for the synchronization, we can go for any of these things. Now you have seen locks. There is a next thing called as R lock. So reentrant locks, I will tell. Next, semaphores, events, conditions, and barriers. Even Python also supports all these things. Whichever you see in C++ and Java, the same kind of synchronization primitives are supported in Python also. So first we have gone for the locks within it. In the locks, I told that traditionally, every lock will have two things. One is the acquire state and other one is the release state. So when something was acquired, till it was released, we cannot use it, right? That's what I told. Similarly, you see here, whereas there is a problem with this traditional lock. So once you have executed, so until it is executed and completed its execution, you cannot get it. If say something is already using like a recursive function, which is continuously using, then until unless it releases, you don't get, right? Then in that case, how to do? That's where reentrant or R locks. R lock means reentrant lock. So what is this reentrant lock doing? So reentrant lock means, so it is something slightly better than an ordinary lock. So what it does is that standard lock doesn't know which thread is currently holding that lock. And if the lock is held and any of the threads is trying to acquire, it will be blocked, right? So it means like if one thread is executing by one of the functions, which is going in a recursive call. Until the entire recursions were completed, that won't give the thread. So sorry, it won't get the lock acquired. So till then we don't do. So a reentrant lock or simply R lock allows it to be locked several times. So means, so it can be released after equal number of releases after the acquire. Means it is slightly different from compared to what you have seen till now. Now let's go for what is that reentrant lock, how it can help us. So going further on this reentrant lock, we can see I told the problem, right? We cannot go hold on the other things. That's where we have gone for the reentrant lock. First of all, I create a small lock. So you see in this example, I'm creating one of the program and I want to execute. Say I navigate to the directory. Python. You see now, I created a small threading.lock. Some thread lock I created. So I'm asking, hey, threading.main thread. So when the Python program is executing, it also has a main thread, right? That main thread name, if I ask, it says it's a main thread. Now I'm saying, is that a thread, this thread you took, right? Is it locked? No, you just created a thread. That's it. Now for the first time, I want to lock it. So I'm doing that. Acquire means you are doing lock, right? So acquire and locked, I'm checking. So now this time, if you see, the first time you're trying to do acquire, means as no one is holding, you can get it. And then you are checking the status. Hey, is it really locked? Yes. Now in this case, you can understand that, so this thread lock dot acquire, it will wait infinite amount of time. So at this moment, so it don't know when to take. Whenever it is, everyone will check for like resources. If something is ready, if they want, they will take it. But how much time they can hold, there is nothing like that. So problem is that if the main thread is like acquired lock, we cannot gain access directly. So if you release an access, then you cannot get acquired by others. So then after getting the release, then again, if you do like, thread dot acquire of 0, you see like this time, so you are acquiring. So when you are acquiring also, you are passing some kind of variable. See here, the first time I'm passing some variable. So now let me do the same thing again. So again, the same acquire we are taking. So, but this time slightly I will make a modification. I am taking some number because like already I did it 2 times right here. So that's why I started with 3. So from 3 till 10 means till 9, it will go. Each time I want to go and check. So can I acquire? You see now. So third time you are acquiring, fourth time you are acquiring, fifth time. So why you can't acquire? Why it is saying false? Because every time it is locked. Who locked it? At this stage, right? So did you see that? Initially when you locked and then you released. Again you locked and again you should release, right? You didn't release. Again you are trying to lock. You can't lock it. So if you see for anything, so if the life cycle hook, if you see, there will be 4 states. First you do acquire lock. So lock, you are checking like whether it was locked or not. Then you do release and release lock. These were like 4 states it would be there. But like this problem is there. We cannot do with an ordinary lock. This thing. Now let me repeat the same process with a R lock. So like same like an ordinary lock, heading dot lock. There is one more thing called as heading dot R lock, means reentrant lock. Same like that here also I created. I am comparing with an ordinary thread lock and this lock. So ordinary lock, and I'm checking this one. So thread lock. Is it locked? I'm checking, right? Yeah, it's my bad. I need to repeat the same. So, okay, instead of that lock, I need to check this one, right? Threading dot lock. Is it threading dot lock? Threading dot lock. Threading dot lock. Same four things. If I execute again, you can notice. Second. Yeah, yeah, now it's fine. Yeah, now I understood. So you did a threading dot log acquire. So this R lock is there, right? If I do R lock dot acquire, even if something is already holding that, it tries to release from it. So even if something is trying to do, so it tries to release it. So in this problem, if you need to understand about these locks and how they are requiring, so I have given like one more problem to solve and to understand like how these problems are coming and how to address them. So more detailedly. But so let's move on to the next thing. After these logs, so there is a better way of handling this using conditions. If you have a conditions, you can better handle it, right? So for doing the conditions, we have a program. So let me write it. In conditions means like, so why we need it? This is also one kind of synchronization only. We do the synchronization basing threads. So in conditions, the first point you need to understand is there is something called as a condition. From thread, we import, from threading, import condition and thread. There are two things you are importing. So first, we need to create a condition. So whenever you have something, you can create a condition. So I do like, so I write my own condition. Condition, see small letters equal to condition. So this is how I created. And you need to understand that, a condition variable is used to represent any availability of the produced item. So to understand this concept, now till now we are just executing something, right? Just like you are generating, you are creating the things, that's it. Now let's change the strategy. Let's take this time two things. One is a producer who will produce the things. Okay. So, and there is one more function like a consumer. So when someone is producing, there should be a consumer, right? So I created like two functions now. There's a producer, there's a consumer. Now in each of the things we need to execute. Okay. So till now, what happens? We need to execute a thread and we need to spun the thread and we need to execute, right? So thread, how can you create a thread? There are two ways. So till now what you do? So threading dot, if I do like import threading dot, so thread we create, right? Same like that. So directly also you can do, like selective import also you can do. The same thread I created. How do you create a thread? Thread needs a target. Target is equal to what are the function. Say like I want to execute one function. Say like this producer. Producer is one of the function which I want to execute. So as of now, it don't have any args. So args equal to empty tuple. Even if you don't write also fine. It will try to execute. Now, once you create a thread, so how do you do? Thread dot join, right? So you do the start and join, right? T1 dot start and T1 dot join. This is how you create and execute any thread. So there is nothing to execute. There are simple functions. So threads will start and execute. That's it. Now, if I want to do the same thing twice, again, so what I can do? I can do this time like T2, T2, T2. So same like a producer, I have consumer also, right? I have two functions. So two threads I am starting, executing, joining. What are the way you want? Maybe like if you want these to be done in a better way, so what I can do for function in, so I can take like a list or a tuple. Maybe I'm taking like a tuple. This tuple will have this producer and like consumer. So I take this one, means instead of these two ways, I want to rewrite it in a better way. How I don't see. You see, I'm taking each time and I'm just executing this thread. How do you create the thread? This is how you create. So you can say like, so t is equal to this thing. So instead of producer or so and so, you can do like function. So whichever is coming, the thread, we can do that thread dot start. And like if you want to start the threads, right? And then subsequently, if you want to, wait for threads to be completed, in that case, we need to do a join. So I told, right, we should not do join immediately. So we can take like a threads is equal to like a list, and each time you're gonna add. So threads dot append of this t. Similarly, you can go in another for loop. So each thread and you can do a span. So that is how you do, right, till now. So assume that like I am doing the same thing again. I am doing that and I'm going and finally creating it. So now you understood, right? Instead of multiple things, I can do in one shot. Till now, I didn't do any logic here. I will slowly tell. So if I execute again, it will execute. And if everything is done, it will say next. Fine. Now, so start will start the threads. As you know, start will start the threads and it will wait for all the things to be completed, as you can be aware. After this, as you have now threads and so, I can now take one more argument and do. So these threads, I can rely on one common variable on which we want to change and do the updations. Maybe like I'll pass one argument. Say like how much time I want to sleep, I will pass. Say n item, n times, okay? N times I passed. So what are the times I passed? I will loop over that much times. So for underscore in range of n times, for underscore in range of 10 times, and I want to sleep for that much time. So time dot sleep of that much time. I want to take like 10 seconds. Okay, 10 is too much. 2 seconds I say each time. So similarly here also I do the same thing. I take n times, whatever n times is there, that much time I gonna sleep. Okay, now if you see here, it will execute that much time. So what is saying, you passed your arguments. Similarly, you need to pass the values here also. So if I say like say some 5, then obviously it will execute for the 5 times. So see here, you have passed 5. What is saying? I take only intervals, not integers. This is the most common problem anyone does. We need to pass a comma, because when you have single value, you need to pass comma. So then executed, it will sleep for that much time and it will execute. So if you want to be aware of things, how they are working, you can say like, so producer. Okay. So maybe like, each time you want to check like how things are going on, you can check the same thing here. Producer I. In the same fashion here also, consumer also, we can do the same thing right here. So instead of that, we can say I. So if I execute this time, each time see here, producer it's going, consumer it is running. Producer, consumer, producer, consumer. Like the two things are executing, right? So now I want to do some kind of change. So for that, I need to have a shareable object, right? So I will create a shared object. Shared object means I create some kind of, values. Values is a list. Earlier, I created a immutable object, right? That's why I created these things. This time I'm creating a mutable object called values. Now, what I need to do before change and after change, I need to tell, right? So, I will create some kind of random number I want to add. So, or like something I want to add to the thing. So this values is a common shared object. Values dot append of, say, what are this number which is creating, right? Producers one or so and so. Assuming that this is a value which I want to take. Okay, value is equal to this one. So I want to append this value. So maybe like, after that I want to print also this value. Okay, so I'm taking the value, printing, and sleeping for that much time, and then adding the value. And like after your work is done, what should we do? So there are two things we need to do, right? Acquire and release. Earlier we took a lock separately and did it. Now we do what? We write a condition and we do it. So I will sleep for random amount of time, and after that, before writing only, you see here, whenever you are writing, so writing on shared object, right? So I before that I did a condition dot acquire. I created the condition object and I'm doing. And after that, after my work is done, I can say like notify. So so earlier people don't know, right? Others don't know what is the problem. Re-entrant means what? If someone is using also, you can take. Then what is the problem? So others who are using, they will miss. So to avoid that thing, a better strategy is like, so condition dot notify. So when you do notify, it will notify others that hey, it is ready to be available. So then like you can say, hey, water is produced. You can tell that. Maybe like this print statement I want to do here. And then I want to like, same condition dot. So after acquire, release. So there are three things, right? So you took the acquire first, then like you are doing the update, then you're doing a notify, then you are doing a release. So release will release the things. Now you see simple logic. Similarly, if you want to do the same things here also, the same thing, right? So instead of producer, we have a consumer. So here also same thing happens. So instead of a producer, we'll have the consumer. So you take it and you print the values and acquire and add the value, right? So now the point is there are two things. Here he is a person who is producing. So producer, what happened every time? It will do the acquire, notify, and do it. Consumer means consumer will not add, right? So consumer will not add to it. So consumer is just taking the values. So there won't be any adding. So we need to receive. So as we are receiving, so here also we try to do acquire, okay, at the consumer side, and we try to print whatever we get. So means like when you do an acquire, we should do one more thing called as wait. So when you do a wait, what happens is like it will check for the value, whether value is coming or not. So that is the difference between here you are sending. That's why you have notify. After adding it, you do a notify. Here it is trying to acquire from them. So what are you are getting from that? You're trying to get it. So means like what are the value which was acquired? Maybe like I'll print after we acquire, I print the value which was received. Maybe like I'll say received. What did I receive? I can say like what are the values are there, right? Values is a list. So I can do values.pop, which are I was sent there. I will get it here. Now I have two things now. I don't need this one, right? Okay. So here also I'm sleeping for same 2 seconds and I'm asking. Hope I'm trying to help you understand these things, how this is working. So producer is sending 0 and see receiver has received it, right? So producer has sent, receiver has received. Producer has sent, receiver has received. So did you all understand? Whatever was sent, the same thing you are receiving, right? Is it clear? I'm making it very easy for you to understand. So whatever was sent, you can receive it. Maybe like, you can generate some kind of random numbers or like, some prime numbers or something. You continuously generate, and whatever it's coming, it will take. So now the state is very simple. Whenever people are producing, there you do like extra thing called as notify compared to the previous one. So whoever is receiving, they need to do a wait. Now after doing it, it will wait for that much time. And now if you want to add more complexity, I can do that also. So in fact, see here, we are not passing this as an argument. We are just doing like this, like a shared object you are doing. So if you pass also, you can do. So without also I can do. I'm just showing you to understand. Is it clear? So instead of like, if you feel like this is a something, so I can create a random value. So random value I can create and I can pass. So maybe like, so producing some random value, I can pass. I can take like, so I'm producing some value randomly and I want to take the same. So random dot randint I am passing. Now is this team, see here, I think still it is going on. Still at the fourth phase, somewhere it is there. Okay, it is restarting. So till then you can see. So whichever value you pass, you can wait it. So instead of sleeping also for 2 seconds, you can modify to sleep for a random amount of time. So it is up to you, like, how you want to enhance. If I say like random dot rand range of 2 to 5, it will sleep from 2 to 5 seconds, something middle. And similarly here also, rand dot rand range, it will sleep for a random amount of time and you get the things. So like that, you can generate and execute the things. And if you want this loops to be run for a certain amount of time, that also you can tell. So that much time it will run. Okay. So this value which is generating also you can pass. So somehow, so like this, you can modify it. Hope it's clear. Is it clear? Okay. So now based upon this, there is one more thing called as semaphores. So what are these semaphores? This is also another kind of synchronization. So same like this one. What are the semaphores? How they can help us? If you see semaphores are also similar to your these things. These are all for like different kinds of synchronizations only. Counter is one thing I told, right? The semaphores are like advanced counters. So acquire call to the semaphore will be blocked only after a number of times threads was acquired. Means like that we can have some kind of conditions. You know what? You are trying to get the values, but there is no way for you to stop. So means like, so if I want to create a so semaphore like condition only, here also you can create. If you give some kind of max number as some 5, so I'm defining semaphore of that 5. If I pass, so this container of the thing, so by default if you don't pass, it is 1. So each time, so what I told, acquire can be acquired after this max amount of times can be acquired. Now let me take that example. Now this time slightly differently I want to show. So I want to create the threads and I want to execute for some amount of time and I want to show you. Okay. So how I can to execute, let me show. First, I'm creating some kind of producer, same like in the previous, define producer. So similarly, I have a consumer, same like in the previous. I need to create some threads and execute for some time, right? So I need to create a threads and each time I need to execute. So for that, see here what I'll do. First, I will create like one of the threads, say T1 is equal to. So from threading, import thread or like direct thread. So thread is like, if you give the target, say like I want to execute the producer. So producer thread I want to execute. So for that, I want to give some arguments. So like maybe some value I want to pass. Say like 5 times if you want to execute. I need to pass an argument at the end. Similarly, T2 I want to execute, which is a thread of target is equal to, so consumer I want to execute. So how many times producer is executing? So that much time. So this also should do, right? So I will pass like args equal to, say like 5 comma again. So now I have two threads. For these two threads, I will execute. Maybe what is the best way? So you write like threads. Threads is like a thing, and instead of just creating, I want to append. So append and just start and execute. So what I will do? So threads dot append of. Can I do like this? Instead of just creating, I can just pass to it. So similarly, what are the threads are getting created? So I can do it, or like directly also I can create, right? Whatever I'm getting, I can pass to it. And I can create, and second one also I can create. So like this also I can create a threads, right? Okay, because I am directly creating this time, I am making it very simple for you to understand. So after creating the threads, what is the process? The below process is very easy. What are threads are there? You loop over them and do start, loop over them and do join, and then do your last thing. This is a common thing. Now I will focus on making the things. So now I want to pass these things. How many loops I want to do, that much loops I am passing, right? The same like in the previous case, as I am passing some arguments here. So here in the functions also it should be defined, right? So obviously I will write here n loops I will pass, and each time when I'm passing within that number of loops, it will loop and it will sleep for some random amount of time and get the values. So for the producers, now I will modify the logic. Each time it will print the current time, whatever is the time it is printing, and like I am doing a container dot release. So what are the container semaphore synchronization container I created? I am doing dot release. So each time when you do try to release, if you are not getting anything, it will throw a value error, right? So when you get a value error, you're trying to handle it. And again, so if there are 10 times it will ask release, release, release. So whenever you are trying to produce an item, so it will just say like that. In the same fashion, when you do then acquire, that's where things changes. Consumer side. So when consumer side, what I'll do, same like in the above, I will sleep for a random amount of time and I'm printing. And here you can see that container dot acquire equal to false, acquire of false. So whenever you're doing a acquire of false, so means like you are acquiring the values. So if not, you are skipping the value. So if it is empty means if the result acquire of false equal to empty means you are not getting anything. So like that, if you want to execute, these semaphores will come. Maybe like, so similarly, there are events are there, synchronizations are there. So that is a too much for you. But like I will conclude with a simple examples. So with concurrent dot futures, that is a final solution, which most of the time, real time, we don't use this mostly this concurrent one we use a lot. So concurrent. So this one we use a lot. Oh my God. Yeah, concurrent features. So if the concurrent features, what happens is like, so this is what we use on a daily basis a lot. In real time, whenever you want to consume something or so and so, this is what we use this a lot. Here, let's say you define some function. We have something called as concurrent dot features. Till now, any module if you have, you are directly using, right? But for the first time, you are trying to do like this. I think it got stuck. My so Jupyter notebook got stuck. That's why it's not showing me further. But like, I think I need to close. Sometimes it will become a stale like this. So because it is a problem with this IDE, maybe because of memory issues or something, it will happen. Okay, so what is this? So till now you have never seen a module like this. So there are some modules which we import directly. Instead of just concurrent, we say concurrent dot features. So can I import like just concurrent? If I execute Python space, so and so. So if I just import concurrent, what do you see? It is executing. And if I say DAR of concurrent, what is this concurrent? How it can help us? If you see, it has a attributes. When you see the attributes, did you see there is nothing? Did you see there is nothing without underscores on either side? So if you say like, hey, give me the help of concurrent. If you say help also, you can notice that it says it's a concurrent directory and you have nothing in it. So it is a futures, package content of futures. So only in the futures you have something. So directly if you ask, it has nothing. Even if you ask, so features, that's where like it has. So certain modules were created like this. So for this, if you ask now with futures, so it should be used only with the futures. Now whatever you get, it will have like that only. So whenever you are importing like futures, you cannot ask like now what is concurrent. If I execute again, say Python space so and so. So you see here, concurrent dot features. You imported, and you are asking here what is concurrent. You get nothing. So if I do like dot dir, now you see the difference. If I see, now you got a lot of things. And similarly in the help also, if I ask a concurrent dot features, that's where you will notice. You see now, it has a lot of attributes. So typical multi-threading, we can do a lot of things here easily. So that is a lot of confusion there. But here it's very simple. So this is all the documentation it has to do. If you understood the documentation of help, you can say Q. It will quit. So after going further into this dir and so and so, what is the most uses of it? Let me take one practical usage of this concurrent.help. So in the concurrent.help, how it actually works is that whenever you have something, we need to execute in a particular way. Say, I have a function called as foo, and it is taking a bar. If you execute it, if I say like print out foo of world, if I say foo of world, you can notice that it is a hello world. Similarly, in the same fashion, if I go further and take like, Python, and it will execute it, right? So like that, any function is there, it will execute like this. So now using concurrency, how do you address it and how to get the values? So using, there is something called as concurrent pool executor. With that we execute. So how it execute is like with. For the first time, you're using a word called as with. With is like a context manager. Means, so there are two ways of doing the things. If you see here, I will tell you. Any variable, when you're using, you can create like this. And finally, if you need to close. So this executor is there, right? Executor. So we need to ensure to close. So instead of doing that, so it can do both together in one shot. When you're going to the file operations, I will explain you much clearly what is this with the context operator. But for now, you understood that with you do it, right? Whatever you create. So here like executor, if I create, this object will be valid only within this indentation. If I come out of this, I cannot use this executor anymore. So what is this executor doing? Similar till now, so what are the functions you have? So same like that you can do. But if I say like, I want to create something, I can use this and create. This executor.submit of what are the function you have. So that function, and if you have any argument, you need to pass. So that result, whatever is coming, that will be coming here. Okay, what are you are returning there, that return will come. So for that future object, you can have a result, you get it, and you print it. Sir, it is just like a small print, right? But of course, I'm just telling in real time how it works. So instead of directly executing, this is how you execute. So this is how, see here, you got the result, right? Return value. In the same fashion, let's say now another example. If you have like a function which is taking two arguments now. So function with two arguments. So similarly, if you have function with two arguments, how do you call traditionally? So print of hello world of say Python and like world. Now if you execute it traditionally, so it says like Python has an age of so and so. I think like I gave a mistake, right? So Python age is like some 25 years. I wrote it. So now for this particular thing, how do you execute? So whatever I have, I need to execute in the same way. So instead of doing directly, I can do like concurrent dot executor. Again, I created one more executor. It doesn't mean I should give the exact name. I can give whatever I want. So here also, I can create a future. Future is equal to whatever you have. Future dot submit of hello world, whatever you have. And apart from that, you have arguments, right? You can just pass loosely. Earlier, we have a target and args, right? So here directly you can pass. So what are the future results are there? You get it and you do it. Here also, future is not a word that you need to do mandatory, but it's up to you how you want to do. So this is how you create a thread pool executor and work. And what is this thread pool executor doing? All these things I will tell shortly. So now you understood how to run a program, right? Using this one. You need not worry about how to implement this concurrency, what is the logs and all these things. So life would be much more easy now. So using this. So here what happens is like, let's say I create one more function. Hope now you can understand how it's working. I created a task. When are you executing our task on process? So what are the OS process ID it will give, right? It will go to the OS module and get what is the task. That's a simple function. Now this function I want to execute. So whenever I want to execute, earlier how we executed, we created a thread pool executor and we executed it. Rather, if you want to do this kind of, this is called as pooling. Means you are pooling some kind of threads and you want to execute with that threads only. So point is very simple. In the background story, I will tell you. So let's say you have some work. Whenever you got some work, then you will hire some people and you ask them to work. And when your work is done, you will ask them to go. So obviously, whenever the work is coming, it will take for you some time for recruiting the people and then letting them work, right? Think in the same lines. Processors also work in the same way. OS also use the threads for different purposes. The moment you have threads, so if you have work, first it will go and check for any threads are available and pull one thread and ask it to execute. Now, don't you think like it will take some extra time for getting the threads? So rather than doing that, they will reserve some threads. So, this is called as process pool. So similarly to threads, there is a process pool also we can do. So what I'm saying, hey, reserve max 3 workers for me. So, and we can use the same thing for all my works. So instead of directly submitting once, I want to do the same thing from now 10 times. Now, what will happen? As you have decided like this, it will be slightly faster if I execute. So Python space. You see now, as I have given 3 thread pools, it is executing. So do you mean like if I give 10, will it execute much more faster? It doesn't mean that. So how much it needs, that's how only it will go. So just imagine like you have, 10 pizzas to be parceled, like a delivery, but you have 100 people. Do you think like 100 people will take these 10 pizzas much fastly? There are only 10, right? But if there are 10 pizzas and you have only 5 people, delivery boys, then you need to ask them to do twice. So that's what I'm trying to say. So if you have 5 people and if you have 10 pizzas to be delivered, then it will be slow. So if you have like 100 people, but only 10 pizzas, then only it makes no sense, right? So that is the exact example I'm trying to say. This is like process pool. So similarly, this process pool also can be used in a different ways. So whenever you're working, and similar to that, there is one more thing called as thread pool also. Thread pool also can be worked in a similar way to be worked. So just same like that, we can have a thread pool and process pool. There are two things. You can pool some processes and pool some threads also. So that's the beauty of this module. So, and it makes the syntax more easy and convenient for us whenever we are working. So we need not worry about all the complex things. Now it's very simple. So whenever you have a thread pool executor, you execute with that. So earlier, see here, I did a process pool executor. Same logic I did here with a thread pool executor. So whenever you go for multiprocessing also or multi-threading also, you can use the same module. So it can help us in both ways. And next I will show you multiprocessing also how to do. But so this module makes a lot of things easy, and you can execute what are the logic you have. Here I have some logic to be executed. So they will just execute. So if I execute like, you see, thread pool executor, so it creates three threads and it will reserve and it will execute. And sir, can I execute like 100 threads? Means if there are like availability, it will check in the operating system. In that operating system, at that time when you took, if there are more threads available, it can reserve. But like, don't be too much, so so aggressive in terms of asking. So whenever you are reserving something, each time you are taking the value, which are you got, you see 45, 45, 45, something values you are getting. And that value, you are trying to get it right. Word saying, so each time when you're executing a task, so did you see the value is the same? So you're getting 45. So why you're getting 45 every time? Because this result is every time inside, right? If you make it as a global variable and make it as a global, then the inside I value will change. But that's okay, simple for you to understand. So, and every time you're asking the current thread. So whichever is the current thread, so it is showing. So current thread dot names, if you say, it will execute. So what I want to show here is that, did you see in all the cases, the thread number is same? The thread number is same. As this is because we have reserved these threads. Though you have reserved 3 threads, it didn't need that much threads. It need 1 thread is sufficient for your work at this moment. And that's the reason for everything it is executing with the same thread ID. So that is what you need to understand. Whenever you do these kind of reservations, so the same thing will execute again and again. So similarly, you have one more example to share in the thread pools to understand. So say this time you have some example. So here I have a test. The moment you start, it will sleep for 2 seconds and return got. And this time I did a thread pool executor and I gave 2 workers and the thread name prefix. For thread name also we can give some prefix like sample. Now we see what happened. So got colon features. So this is like a syntax for you to understand, like what is the type. That's it to understand. So got is a variable I created and I'm doing sample dot submit. So if I do like sample dot submit, means what are this? Like earlier we create a thread and we executed, right? Here we creating like this pool. For that pool we are submitting. Same executor, some way. And finally you are getting the result from it. And finally, so you can do a shutdown also. Means after your work is completely done, you can shut down and ask for others to execute. So like that also you can execute. So shutdown is another thing. So cancel features means after work is done, it will cancel it. So point is very simple. Whenever you are reserving, it will try to reuse the things. That's the main thing here. And one more last example to show here in the thread pool executors is that, so whenever you have, say this time, I created again one more task, a very small task, and using thread pool executor, reserving these 3 threads, and I'm asking. And this time you see here, within the context itself, I'm asking 3 times. So in this case also, you can notice the same thing. You see now? So each time when it is executing, so the thread, so values, and you see here, the first one is executing, second one, third one, like that it will be processing and executing. So this is all about multi-threading. And the next thing is about multiprocessing. So, and like we will create a new module. So coming to the multiprocessing, it is not that difficult, like what you have seen till now. So multiprocessing is slightly easy. So in terms of working, because like multi-threading is also easy in fact, but there is a problem with Python. So in implementing, so that's why we cannot see all correctly. But like still, it is not a bad thing. So we can use it. And coming to the multiprocessing, how we can work on it. So let me take one example for you to understand. Let me take multiprocessing module, import multiprocessing. If I do like a dir of multiprocessing. If I go here, see now, it has a lot of attributes in fact. So arrays we have, so authenticator error, barriers. So same like bounded semaphores. What are your length? Their conditions, events, logs, R logs. So what are there? Here also we have them. And if I take this time one small example, so the example is very simple. Let me take like a function, a small function, which is a doubler. If you give any number, it will multiply into 2 and it will print that result. And during the process, it also takes the os.get process ID and prints that process ID also. So this is a simple function. And now I want to execute the same for some number of things. So I have taken a numbers, like numbers equal to something. For each of the numbers, I want to check. So for each of the numbers, I want to do, say, for number in numbers, I want to create a process. How do you create a process? Multiprocessing dot process or executely you want process. Same like a thread, here also target. So which are is the function, tabular. And if you want to have any arguments, you pass that argument. So you want like number, which is a single value, you pass like that. And you can tell like this is a process is equal to something. And maybe like you can have a processes, procs. You can take like a procs, and each time you can do like, so procs dot append of what are the proc you have created. So this is how you do it there also, right? After appending, so for this particular proc, you can, so proc dot start. So it will start the process, right? It will start the process. And then like you want to do what? You want to loop over it separately for joining them together. So separately you do a join such that you can join them and execute again. So the same syntax, what are you see there? The same syntax. That's why it would be easy for you to learn now. It will not take that much time for you to understand. Now, if I execute this program again, you see, it will start for each of the numbers. It will start executing. So what is saying? Hey, freeze support. Multiprocessing freeze support. Okay. If I execute again, yeah. So each time I'm passing one value, and it doesn't mean like, what are it's happening this time. Okay, earlier I passed all the numbers in one shot. That's the point. Okay. You see now what happened? Each time creating the processes and I am executing. From 5, 10, so and so, everything I started executing. Now you see, everyone executed, and everything is much more faster in fact. So why it is executing that much fast? Because of this thing. Multiprocessing will reserve separate resources for everything. So due to that, like it is executing this much fast. And similarly, if I go for one more example now, the previous sleeping problem. Every time you sleep, right, for some time, just to make sure that like you have a big process. So this time I'm taking like sleep, task sleep. If you have given a task number, it will take that number and it is sleep for the duration and print. Whenever it is printing, it will print the duration also. Now in this case, I am creating like 2 threads. So first I'm starting like this. I'm taking a start time, creating 2 processes. It is taking 2 arguments. So I'm passing 2 arguments. And then like what? After that, we need to start and join, right? So I'm starting and then joining. So finally, after everything is done, so I want to take the total time taken. Now if I say here, Python, in this case, see here, everything need to sleep for 2 seconds. And first one is the first task, second task. Did you see how much time it will take? So both are sleeping for 2 seconds. So first one will start and sleep for 2 seconds. Second one will start and sleep for 2 seconds. So if I do the same thing in a traditional way and doing like this, there is a difference, right? If you want to know the difference, so first you can do like this, and so using sequentially. Sequentially, if you do also, you can notice the difference. Of course, next I will show a comparison between all 3 in one shot. But generally, if you take like, so the same start time if I take, and if I execute this end time, and before that if I ask, say task sleep of same 2 comma 1, say task sleep of what do you say, 2 comma 2, if I pass, this is like sequentially, right? You don't pass to anything and you want to execute. So in this case, see here what will happen. In a sequential way, if I execute, and like this you execute, even for the small things you don't observe big differences, but for larger things you will observe a lot of difference. Even in this case also, did you see the difference, how much time it took? So it took like really more time, right, compared to the sequential. Maybe like I should execute the sequential first, followed by this one, right? So I can write the sequential first. Using sequentially, it took this much time. So using like multiprocessing, it will take this much time. So don't you think it's an advantage of going for this? Okay. And if you try the same thing with the multi-threading also, you can observe the entire difference. So how do you create with multi-threading? Again, you create 2 threads, start, execute, final, right? So let me try doing the same thing here. So like this. So if I want to do with that multi-threading, you see now. Multi-threading means what? I need to take import multi-threading. Multi-threading. Multi-threading is not coming. Why it's weird? It's not taking multi-threading. Oh, threading module, sorry. Yeah, threading. So for multi-threading, how we do? So threading dot thread, right? Yeah. So same logic, same arguments. So here, so threading dot thread, and here also threading dot thread. So here we create a thread. So for convenience, I'm not changing anything. So creating a thread, executing, waiting for thread to complete execution. So three types I have now. So first using traditionally, so means a sequential execution. So second one using directly, and you can see all these 3 differences. So did you all understand how much time each one is taking? So comparatively, if you see, so multi-threading, multiprocessing, and sequential task. If you see these 3, so now you'll understand, right? Comparatively, sequential is taking more time, and the multi-threading is taking 2 seconds, and multiprocessing is taking like 2.15, right? So you can see here relatively multi-threading is taking much faster. Of course, that's how it should work. So, but like, so when you go for bigger tasks, that's where you'll notice the difference between these two also. So that is fine. So now going further, compared to this, here also like thread pools, processes, and others. Here, what we can do, what are the process pools we created there, right? Using different modules. So here also we can create a process pool. So here multi-processing was more matured, I would say, because more people use it, right? So that's why it was much more better in terms of access and everything. I created a worker which is taking a name and it's not returning anything, just printing it. So what it does, I created some process names, and I created a process pool of 5. So multiprocessing.pool. I'm creating process of 5 pools. You see here, this time, whenever you have a pool, we are doing a map. This is what very interesting. So what are the processes you have, that processes you need to map. So then like this worker, it will execute. Maybe this is a slightly syntax first time, right? You may be confused to understand, but it's very easy for you to digest. It is a simple function which we want to execute. And for executing, so first I create a pool, and to that pool I will map this, what are the function I have and what are the values I need to pass. So means like it's very simple. So till now you have a function means what? You execute like this. Like, say first, or like, worker of, say second if I want to pass. Second, or like, worker of, say third. I want to execute like this. Now what will happen? CLS and Python, say if I do process pool, it will, so it's a general execution. Now I want to execute the same thing with a pool. So for that, what I can do, I can take a pool first of all and execute. So traditionally how we do, you create a multi-process and do, right? So here, when you want to create a pool, I created pool like this. So I'm creating like 5 pools. In max, only 5 processes need to be taken, and it will reserve them. And for that pool, say pool dot map of, I want to execute this worker process. Each time I want to execute with different values. So now you see here, if I want to execute for different values, I need to pass like first, so second, and I need to say third. How do you execute if you want multiple functions to execute in one shot? How you execute? Even in traditional approach also, if you want to execute, how you execute? You can say like, so each time you have some values you want to execute. Then what you do? So in a loop, okay, so worker of each, for each in, you take like a list and you pass to them, right? You take in a list and you pass the values, right? This is how you execute when you have multiple things. For the same function, if you have multiple values to execute, this is how you do. Or a better way is like you have a map function. For that map function, you pass these values, right? So don't you think you do like this in real time? So like this, or here like this, use a map. The same thing we are doing here, map. So if I do map, so it will execute. And if I execute, it will find. But the point is like when to stop. So for the pool, we should tell like, when to stop. And it is stopping like, easily. Why it is doing like this? Means you cannot execute them directly. It's crazily going. So we need to do within this condition only. If underscore underscore name is equal to underscore underscore main underscore underscore. Why, sir? Because it will be confused. So this is one of the best practice for other things, and here also. I'll stop. It is continuously going. See, I'm doing control C, means like I'm trying to stop. Even if I stop, other process is running continuously. So the point is very simple. The main thread will call the main function, again the main function, like that it will go on calling. So due to that, this problem comes. If you want to solve this problem, we should close it. That's the best way. to stop it and open again. Close others. Copy path. Navigate there. Python be so and so. Did you see the now importance of this if condition? If name is equal to main. If that is not there, it will crazily throw. So if that is there, fine. So every time you should ensure that whenever you're going multiprocessing, multithreading. And simple, right? Whatever I told. If you want to pool something and if you execute for the same function, if you want pass different arguments and execute, this is how you pass. So you need not worry about like how you are executing. This is how very simply you can do. Okay, is it clear? Hope you understood how you do the process and execute them. Similarly, there is one more thing called as a star map. Like a map, there is one more thing called a star map. Star map. If I go for star map, how it works is, that is again another simple function. So here also, the same is like that. I am showing you something. You created a function. It will sleep for that much time and it will print, right? The previous program. Same like that. Here also we are taking a pool. I told like we need to pool for like two process we will doing. So then like instead of a map, I'm doing a star map. Star map means like you are passing like an iterable. Same like a map. It is slightly better. See you are passing an iterable, right? And here you are doing some operation. So it is containing two values, means 2 into 10 into 10 means like you are getting a list of these much things. If you see IPython, you will understand. So I am doing like this means, so 2 1 2 1 like that. Every time two arguments will be passed like a list of lists. Okay, so better way I'm doing. So if I execute, you see now, like B, you have like B1. If I execute, you can see that it will execute for all the times and you get it the result. You see what are the tasks which is executing. It is executing for that entire time and you are getting the result. So same like the pool, but here the difference is simple. For a ordinary pool, so you have like pool dot terminate, but like here you have like a pool dot close. So once everything is completed, then it will close and give the elapsed time. So if I say like so completed here in the ordinary pool, if I say like so all done. If I say all done here in the earlier example, Python B so and so, if I execute, it will all execute. It will finally do and terminate finally, and then done. So that is the beauty of terminate. Means everything will be stopped. Whereas here in star map, the same like that, but it will pause. It will wait till everything is done and then it will close. And in the same fashion, you have like worker threads. You can create like different kinds of workers. I think I created a good examples also. 1 second. Is there anything pending? Okay. So the last two things in the multiprocessing to be aware is that pools right now. You are reserving certain amount of time and you are executing them. Now, similarly, if I say in the queues, what is this multi-threading queues? Multi-threading queues means queue. Hope you are aware of queue, how a queue works. Queue means like you will have some buffer. So whichever pass to it first, that will come outside. Just imagine like a tube. So in a tube, what will happen whenever you go to any pool, like a swimming pool near there, if there is a tube, whoever comes inside, they come outside, right? First. So are like bus queues. Anywhere you see the queue mechanism. Queues will work with a FIFO, means first in, first out. Whoever goes win first, they will come out, right? First. I'm doing. So here, what we are doing, whenever we are passing a queue here, so you're taking some random value and you're putting into that queue. So you are sharing anything. You are just getting it as it is. And see here, we are creating a queue and we are generating some processes. See here, you are creating a process. So this is very simple to understand. You are creating a process and for like each of the value. Instead of doing in a single for loop and doing, I'm doing in a comprehension, that's it. So each time you're creating a process and you're passing the queue. So the queue which you are creating outside, that you are passing as an argument and you are doing it. Now see what will happen. Every time within the logic also, the results you are passing to that queue. Means this way you can share the resources. After your work is completely done, you can do it. Now you see, you start it, you join it, everything is done. Finally, at the result side, so wherever you're consuming, you can do q.get. So whatever you did it, you can get in one shot. So everything can pass to that queue and you can retrieve from that queue. I hope you understood how the queue is working. So similarly, so this pool is there, right? Earlier we have pools. Same like here also we can have pools, but that pools we can enhance a bit. So these pools earlier means what? You were reserving some kind of workers. Hope you are slowly now understanding about this multiprocessing also. So in the multiprocessing pools, the next big thing I want to tell is that till now you are aware that there will be a multiple processes means if you are doing a pool means you are reserving some things. Okay. So here one more step to see is that let's say I created a long time task. I'm taking a name for that. I'm just running it. So I'm taking the start time. I'm sleeping for n amount of time and I'm just taking the end time and I'm printing. Means like what are this long term task was there, it is executing for that amount of time and you're getting the answer. So till now uh, you passed to a poll and you want to execute. So how do you do? Traditionally how it works. Now I don't want to compare. The main process is also there, right? For main process also there will be process id. I created this time a pool. Did I reserve any number of workers? No. And then I executed for 5 times. So for this pool I am apply async, sorry. Apply async is very interesting. Earlier you understood about reserving some workers, right? Here also I can do workers, I can reserve like 3 or 4 or 2, anything. So that is not the point I want to tell here now. If you reserve something and if you execute, all of them will execute, right? And they were related. And if you do apply async, the beauty is that once if you do .p.close and then join, I'm doing, see here, did you see that I am not creating the task like traditionally? I'm not starting and joining. See, I'm doing a close. For the entire pool, I am doing close and pool.join in one shot I'm doing. Now, in this process, if I do, two things will happen. Everything will execute in a asynchronous fashion. Asynchronous means one will not rely on the other. Means, let's say initially only I'm writing the print statement. The first process ID, what are the process ID? It will give print it. Then after that, so did you see what is the second statement? Means it will start create the processes and it will not start. And you are saying like waiting. And after that p.close means I created the processes pools and it is ready to be run. Then the moment you did a join, it will start executing and doing it. And did you see that each time will execute separately? That's why all were started and everything based upon the random time. They are sleeping for X amount of time and you are getting the results. So two things I want to bring to your notice here in this program. So pool, till now reservation is okay. You can pass any number to it. It will reserve those many workers. Apart from that, till now you're doing map or star map for like applying something to a function. But all will execute in some kind of sequential way. If you want to make them to be more async in nature, so there is something called as apply async. You pass on them and do, but the syntax is slightly different. So instead of you creating a process and passing it, so you close and you do join, it will execute in the backend. So this is what I want to bring to your notice. After that, so I want to lastly do the comparison. So if I do till now a lot of things we did. So Z, if I say comparison, earlier also I showed the comparison between these three. I will bring one real example for you to show how I do. This is one of the real example I'm bringing to show the differences between these three sequentially and so and so. I think I explained this already, right? Okay, then not needed. Fine, I think I not needed. So I explained this already. Now finally, so we can see about creating a user-defined modules. How do you create user-defined modules? How to work with that? To understand that, let me show very thing simple. So after these files, you want to create your own module. Maybe like things are very big enough. I want to create like user-defined modules. User-defined modules. Okay. So to make the things easy for you, instead of you focusing this much things, I can open it in a separate folder again. Open folder. So again, the same path I am giving, just the same thing will open. This time only your files and everything will come. So it may seem like, it is the same. Yeah. Okay. Again, the same paths, everything is same. For you to be more focused on here, I am doing like this. What I want to show here, if you see, first I want to create a package and I want to do the things. What is this package? How this things works? So let me do. Okay. Okay. So I want to create a package called as say my package. I want to create like a folder. So there are two things. We can create like a file. We can create like a folder. So you see, first I will show you how to create a file. File means maybe like I will do a calculator. Okay, .py. I created calculator.py file and I want to do some operations. So generally, if I do like simple functions, say like addition, I don't do anything, just pass, define, subtraction. I don't do anything, just pass. So like this, I created two functions now. So similarly, I want to do some kind of usage also, means I want to reuse somewhere else. So usage.py. So usage.py, I'm creating one more file for you to better understand. Okay, you see here in the usage, first I need to import whatever was created there, right? So you see here, I have created the calculator module. I want to reuse. So I am doing import calculator. Instead of .py, as in the current directory, I can just use it. So if I do like, just I don't do anything. I go to this directory. I see what are the list of files. There will be two files, calculator and usage. Now we see what will happen. If I say Python space usage.py. So first I do calculator.py. As calculator has nothing will execute, right? Again, if you see the list of files, again the same thing. Whereas if I say Python, the usage means I indirectly executed the Python script, right? Calculator. That's the reason. Did you see a new folder came called as ._pycache? In Python 2, they used to come directly. Now in Python 3, they came like this __pycache. These files will not go into your Git repository, but this is how it is. Calculator.cpython 3.11 pyc. This is what you need to understand. Means C Python. I told, right, Python don't have its own compiler. It relies on some compiler. So for that, it works like this. So, and 3.11 is the version which I'm using, C Python. That's the reason it is saying, okay, open it. So if I say like open anyway, maybe like I want to say like text. Did you see, you cannot understand anything here, the code. Only thing you can understand it is some path. So it is so like a garbage kind of thing, right? So that is a bytecode. Means Python code, when it is going to the machine, first it will convert its own bytecode. where it can do things much more faster and all these things. That is that bytecode. And next step in this bytecode is going to the machine and doing. As when you are importing, every time it need to do this kind of thing and do, for better usages, they create this bytecode. So now you see each time how things will work. Very interesting. If I this time do the same thing with like in that module, I want to add some features. So like I want to do addition, subtraction, I want to do. So with some more logic, I want to do. And if I say like, yeah, you created, right? Earlier you are going for DIR of everything. Even if calculator also, if I ask the same thing, CLS, Python usage. You see now, if I do DIR, I will need to get the list of attributes, right? Did you see here in this file, you created just two functions. See how many attributes came? Who gave all these attributes? Did you see that you defined? No. So they will give by default. This is called as a metadata of a file. So if you want any file metadata, so file means Python script. Python script metadata. Metadata means data about the things. Means what are these things, sir? Do we know? So the moment you install Python, so and everywhere use some built-in functions, keywords and all these things, they will come with this built-in only. That's the reason the moment you install, you get it. So that's the reason, see here, if I ask, so print of f of, if I say, hey, so this calculator dot underscore file is equal to, now you can understand what is that? It is giving the entire path, right? Where this calculator file is present. Means tomorrow, if some file is stored somewhere else directory also, I can import. And similarly, not only that, so there is something called as underscore doc. If I ask, hey, what is the documentation? Then it will give. So CLS and Python, so usage. Did you see that documentation is none? Because in the calculator module, you didn't write any documentation. What is the documentation? Hope you remember, I told something here. We can write a documentation, I told, right? So I told like any program, shebang line is optional. Even if you write or not, you can create a document, I told. I wrote like this now. Now this time if I execute again, did you see I got the entire documentation? So maybe like, here, instead of directly doing, so I want to just print it. Print of calculator dot underscore doc underscore. Now if I see, if I execute, did you see what are the documentation is there? Exactly I got here, right? So this is what I want to prove. So these are the attributes which are like metadata. Even if you don't create also, they will come. So after doing all of them, you have two functions. So you can ask the help for the function also. I can say like, help of calculator. Now you did DIR and calculator help, right? So here also I want to do DIR and calculator. When I did the help, did you see I got a standard documentation? Same like your built-in modules. Here also we got it. So what is that you can see here? So whatever you wrote there, see what are the documentation? That docstring came as it is, right? So this is like script level docstrings you got. And what it is saying, it is name is calculator. How it got a name calculator? Because what are the file name is calculator? You got it. And similarly, it got a description. So what are the docstring I added? Again, the docstring came here, right? So similarly, it is saying it has two functions. And there is no logic about it and where the file is. Now, I want to enhance this a bit. So in this main code, I want to add like this. Means apart from these docstrings, I added two more functions. For each function also, I added a docstrings. This is like standard RST format. So to say like what are the inputs and what are the outputs. For this function, it is take two arguments and result is so and so. This function is having two arguments, result is so and so. And apart from these two functions, I took one constant called dozen is a number. Now we see the same syntax, it changes. So what are the script level docstrings are coming? Those are coming here. And description also the same thing is coming. And also what are the functions you have? Those function level docstrings you are coming at the function levels. And apart from these functions, it is showing a separate section for data. Means what are the constants are there, that is data, and your files. So hope you understood now how it is working. So now in terms of usage, you can also tell like how to use it. Maybe like here I come here and say like, hey, print of calculator dot addition of say 10 comma 20. I want to do this operation and get the result. F of. So F string assignments made a lot of things easy for us. You see, you got the result. Instead of you defining everything, you are just executing. Maybe like I want to do the same thing for a subtraction. I get it. Similarly, I want to do multiplication. So can I do like multiplication? No, because you didn't define it. So if you are not defining and using it, it's saying attribute error. Now, did you all understand in which cases you are getting attribute error? If that module don't have anything, you cannot get it. That is how it works. So if I go further and if I create one more module like this, so called as a multiplication, here I defined. No matter how you define, you define. Now in the other side, you can come here and if I execute, so it is saying like there I wrote like multiply, right? Multiplication. I think some spelling mistake. Multiplication. So the same exact multiplication we need to use. I think I exactly give. No, it should work perfectly, right? And did you see that the multiply didn't write any doc strings? That's why in the multiply it is not coming. And one more thing. So you define first addition, next subtraction, then multiplication. But it is coming in a different order. This order depends upon the alphabetically. A comes first, next M, next S, right? So alphabetically these functions were printed. So though you define anything in any order, it will come like that. And similarly, so you can ask for division. So there is one more thing as division you can ask and do. And before that, I will tell you one interesting. The same like usage in a file. You in interactive mode also you can go and execute. Stated that you are in the same directory, you can execute it. So how do you know? Import OS. So OS dot. So get current working directory. Sorry. Get current working directory. You got it. So OS dot list dir. If I say I got these things right, same things. Now, don't you think that I can do import calculator? Calculator, I did it. I got it. If I say dir of, so calculator. If I see now, did you see I got, apart from these constants, see these things. See which are is constant, they are coming in the top, right? So means like the constants, variables, and these things. In an alphabetical order, they will come. Now I added one more function called as division in the main function. And after that, if I ask, hey, dir of this thing, did you see? You didn't get it? This is what very, very important point. I'm telling again and again. If you have a program and you are reusing something, so here I can add one more thing. After this multiplication, I can add division and I can ask a division of something and I can ask. Because programs you execute again and again, whereas interactive mode is different. When you change the original module and you in the interactive mode, until you come out of it, you cannot get it again. Say that you are working on some big machine learning code or something, but suddenly if that is not there, then what will happen? That's a problem, right? So then how do you solve it? So in this case, there is a module dot reload. So we can do like module dot reload to do work on it. Yeah. There is a module dot reload. Yeah. Portlib dot reload. Yeah. So okay. It came like this. So there is something called as import import lib. This is another module called as import lib. What is this module used for, sir? Now means this module will help reload anything. If you want to reload anything, so import lib dot, so reload of which are module you want to reload? Calculator. So calculator, if I say, it will reload now. It is reprocessing again and doing it. Means again, if you delete a PYC file, it will recreate. I just didn't create to show you. And now you see the DIR of this calculator again. Did you see now division is also there? And to prove that it is doing again, I can go and delete the entire folder. You see now? And if I again ask for like import reload, did you see that it is creating again? So every time you execute this tab, it will go and recreate this PYC file. So how it actually works is that this PYC file is also very interesting. Whenever you're doing any imports in an ordinary script or somewhere else, so it will check whether the main file, last updated time is greater than this. Then it will recreate it. So for when you are using in a Python scripts, you don't have any problem. When you're using in interactive mode like Jupyter or IPython, that's where you have a problem. So that's where you need to use import.reload. Hope you understood in which case we need to use it. So I'm coming out. So if I do like, quit, fine. The script mode, there is no problem because every time you rerun, right? So you don't have any problem. If I say usage, it will execute and it will show all the division and everything. Whereas the problem will come only here. And one more thing. So in the main script, whichever you want to take like this kind of thing, so you can take like this and do. Okay. Did you see now? I told there is something called as file. Any script can be executed two ways, directly or indirectly. If this calculator function, if I'm executing directly, did you see it will give its file name? So the same thing you understood. And also I told underscore underscore name underscore underscore, right? If your file is there, if you are executing directly, this name will be equal to underscore underscore main. If you are doing indirectly, so it will be showing the other side. Now the same thing if I execute via the usage. If I do via the usage right now, did you see it will show all the help and execute and do? And did you see what will happen? So indirectly executing, the script is executed indirectly, it is saying, right? So that is how it works. And similarly, if I want to create one more module called as this time operations, same like this calculator, I want to create one more thing called as operations. So for this module also, I try to add, maybe like I added two functions called as calculator and Fibonacci. Okay. So why we need to write this condition, I will tell right now. If I assume that I'm writing without that condition. So I told you again I'm telling. If I say Python space, say operations, if I execute, I created two functions, one for factorial, one for Fibonacci. It will execute both of them, fine. Similarly, if you indirectly execute, indirectly means either in the Python script, another file you can execute, or in interactive mode you can execute. Let me show in interactive mode. In interactive mode, how you do? So either way, only when you import, that PYC file will be created. If I say operations, right? In this directory, there is an operations. I just execute. See, the moment I created, did you see a new file called as operations PYC file was created? And the moment I imported, did you see the values also executed? Just imagine, right? Someone has written a logic for logging into a server and they wrote a logic to connect to their server and you are reusing their script. So what if they, when you're using that connector function, it is also doing, that is a problem, right? To avoid that only, we need to write this if underscore underscore main is equal to underscore underscore main underscore underscore. So if you want to do execution only when directly asked. In other cases, you want to just pass this as a function. If I import again, what will happen? Nothing will happen because it's already imported. It is like this. Then what is the solution? Now you see here, if you want to know, either I need to close the terminal and see, else what I need to do, import lib and import lib dot reload of, instead of a calculator module, I need to give operations module. If I give right now, so it is regenerating it. Now after that, if I say, hey, import operations, you see nothing is happening, right, this time. So when you make any changes to the function in the interactive mode, if you want to get the changes immediately, you need to do import lib dot reload. Okay, sir, I come out of it. I want to execute again fresh. So again, you open a new IPython notebook. It makes no difference, right? If I do like operations, so it imported, but nothing was executed, right? That's the beauty of it. So if I say now dir of operations, you can notice all the attributes, and I can get the help of operations. If I execute, you got all the help. So what are the things are there? At the script level only, right? I didn't write the documentation too much. So whatever I wrote, I got it. So now you understood. So maybe like, I can write different kinds of helps, different kinds of usages. So maybe like I want to write another function called as for operations usage. You can write like indirectly. I did indirectly, right? So using interactive mode. And this time I want to do directly. And this time I want to show you one more interesting thing. So like this here. So till now you are importing the operations, you are working on it and doing the things. I want to show some interesting things. So you have bytecode files created, right, already? I will just delete them. Bytecode files deleted. I'm just executing them. Now you see here, there is one more thing I wrote right now. Don't write bytecode. So till now, these files are not there. Then whatever you import and execute, that will happen, right? If I exit and see here, so Python space usage operations. If I execute, did you see the moment you are importing anything? So you see bytecode file is created, right? Operations. As just now used only this one, it will happen. Now this time I write it. So sys dot don't write bytecode. And again this time I delete it. You see here, delete it. So now again I execute the same. So it is going and executing, but did you see that the PYC file was not created? If at any point, if you don't want to create a bytecode file, this is how you can do. Or in which cases we can use means sometimes we need like that. We don't want to any new changes. Sometimes someone makes some changes to the modules and you don't want the changes to come or anything like that. The existing PYC files you don't want to touch. So in that case you can do. So that is how you import it, right? Fine. So till now, this is what straight away way of importing. There is another way of importing also, right? So selective import. Selective import, I told you. Selective import means what? From operations, import whatever you want, like Fibonacci. So instead of directly executing like this, I can do like this. So I can do like operations. Okay. So I have only one thing I want. I can execute like this. Both ways I can execute. This is like selective import. And there is another thing called as a wildcard import. This is not recommended in fact, but like from operations, say import star, means everything will be imported now. Means, so whatever you did earlier, the same things I can do directly. So without any thing, so no prefix, nothing, I can do directly. So not only that, whatever it has, everything I can import. You see? So there are three types of imports: selective import, wildcard import, and so on. And now you understood about the bytecodes, right? And one more point I want to tell about this don't write bytecode. You cannot go to every program and write this a flag that, hey, don't write bytecode. If you want that to be explicitly done for entire project, you can do like this. In the environment variables, there is one thing called as don't write bytecode. So if that environment variable, if you are doing this set, so then you can see that it will not create. You can try that also. it will work like that. It's fine. So like this, you created multiple things. Now you want to execute and use as like a module. So how to use it like a module in somewhere else? So let's say this module is containing 3 values. Now you have calculator and operations. 2 things are there. You want to use them. Then see what will happen. If I have these 2 things and I want to use, how I will do? I need to create a folder called as say my package. See, module is different, package is different. Individual programs are called as modules. So whereas if you want them together, that is called as a package. So means I have these files, right? I want to pass all these files into it. I'll pass on all the files to it. All were gone. Now I want to use like a package. So I would say like usage package.py. Okay. I'm using the package as it is. So this time I am doing like import my underscore package. I want to import. Now you see what will happen. So if I try to import, so if I go to for you to understand. So if I do a ls, should be there in the directory. In the directory, I should have my file. So usage Python package and also that folder. Now, if I say Python, usage Python, what happened? It did nothing. If I say like, print off, hey, so print what is this? Any module, if you are trying to package, if you are doing, it is saying like package so and so, Trojan external something nonsense it is showing. So any package we have, or package is also like a module only. So whenever you got, so you can just get the DAR. Did you see what you got? So the moment you did, you got nothing. So it has like these many files, right? Calculator operations. Did you get anything? Nothing, right? So why this is happening? If I execute, nothing is happening. Now I will do a magic. I'll create a new file within that called as underscore underscore init underscore underscore dot py. I just created one empty file, that's it. I don't write anything. But again, I execute the same thing. Did you see what happened? A new PyCatchy folder was created and it is saying for a init it is doing. Means I am taking these things I'm telling. Okay. Hey, it is also PYC file. For the init file, what are you created? It is doing means. So, but if you see the DIR, you got nothing. Even in this case also, after writing, now it is something better, but still you didn't get it. Now it is saying like this package is located at the location and so and so. Sir, okay, sir, we didn't get. So can I do like this? So print off like my package dot calculator. Can I do like this? If I execute, what is happening? If I execute, you see, it don't have an attributed thing. Then what is the solution? Means you need to create a init file, and within that init file, we can say like all is equal to within quotes I write like calculator. So now in this case, see here within the init file, I wrote like this all is equal to like a init. So I wrote the moment I wrote like this. So you can notice that. So what are the modules you want in it? So I want like calculator. So I want like, operations. So if I execute, module has no attribute calculator. It should have it. Okay. So directly it will show. Yeah. So if I say like the same things here. Okay. Package usage. So the package usage, if I say here, you'll notice that I'm asking these things. Let me show you the DAR and others. You see now the package name. So documentation, file it won't show, package it shows, fine. So after that, this is where we are asking, right, DAR. So this time you see here, it is showing the DAR of all the attributes without it. So now, if I try to ask for any of the things, so in the package, if I say like, hey, give me the constant or addition or something, if I execute, it is telling that, hey, in the package, there is nothing like a calculator. But in fact, in the package, we have calculator. So we have, then how to it? So ignoring this underscore package, if you see now, what is happening? You have a calculator file. So you have these things. Then what is that we can do? So this is more important point. So you need to specifically import it. Within the init part feed file, you need not write the doc strings. So you can write, if you want doc strings, you can write. But the only thing is like you need to just import it. So if I do import, now you can see that it will execute. The only operation you need to do is like import it. So if you do import, you get it. So this is how. So first you created files. Individually files you can extract. But if you want to do like a combine, like a package, this is how you do. Similarly, I take like one more package, say some package. If I say like a package, this time I create some files and have folders. This time I'll make it very simple for you to understand. So I create some modules within that. So module one. So within module one, so I want to pass everything. Okay. So earlier, those others. You see here, I created some classes just for you to understand. So similarly, I created one more module. In fact, this is one of the interview question. So I created one more module and I'm doing like all. So this one here. So I created one more classes. And in the third one, also I created. So this time I created one more module called as module 3. And I added one more class called as so-and-so. Now I have 3 classes. And within the constructor, I want to import everything. So there are, I need to, if you want to import, so first I need to create an underscore and need underscore dot py file. So within that, I need to import everything, right? Say from module one, import star. So from module 2, import star. So like that I want to do for all, right? So that everything I can get. Module 2 import star, module 3 import star. If I do like that outside, so I want to use that package, right? So another thing I am writing, right? So usage.py. One more file I'm writing. This time I want to use it. How do I use it? So whenever I am using, it's very simple. I can outside ask like, hey, give me the values. So import package. I created just package. If I say print of dir of package, if I execute this program, you can say Python space usage. Did you see now? This package is another thing. So I'm just greeting with a name for that you can understand. I'm asking the list of dir. It is saying no module named module one. So did I give the exact name? Okay. So it is trying to get from it. So module 1, module 2, yeah, like that it is. So in fact, it should understand from the working directory, it should do. So you didn't understand why it didn't do. So I can do like import pdb. So and like, so pdb dot set trace. This is how I do debugging, right? I place in the starting for me to understand. I am re-executing the program. It is going there. So I am within this constructor file. I want to check like import OS, and I want to check like OS dot get current working directory. It is in the some user in this main directory. And from this you are asking like, hey, So os dot listed AR. It is said at the directory it has these things. So in this, you are asking to check within these modules in this location. But how can it know that where to check for these modules? It don't know, right? That is a big problem. So this is a big crazy thing. So means like, as you are outside, though module is somewhere else, as you are accessing from outside, you should tell like this. Means from package, my package dot so module 1. So if I say, then it will execute. So you see, instead of module 1, if I say package dot module 1, so similarly package dot module 2, so similarly package dot module 3. If I execute like this, it will work. So if I remove this, because like my debugging was done, I removed it. So I just want to come out of it, quit. If I re-execute again, this time see it is executing. Now did you all understand how it is executing? Whenever the package dot module import everything, package dot module import everything. So like that you got.